This video is a review of how to solve algebraic equations. First, let's review any key vocabulary in order to help you be successful in solving algebraic equations. First, we want to review the term equation. An equation is a mathematical statement that two expressions are equivalent or have the same value. Inside algebraic equations, there are letters or symbols used to represent unknown values. Those are what we call variables. Other parts of algebraic equations are what we call a constant. A constant is a value being added or subtracted in the equation that does not change. For example, if you look at the equation here, on the right side of this expression, the variable would be x. The constant would be the -4, since you will always subtract 4. Now let's discuss the key terms when solving the equation. First one that we want to focus on is what the term called isolate the variable. What this means is to have the variable on one side of the equal sign and the other expression on the other. No other operations are attached to the variable. In order to do that, we use two properties, inverse operations and the equality property. Inverse operations are simply operations that undo each other. For example, addition and subtraction are inverse operations, multiplication and division. In an equation, though, you must remember that both expressions are equal. That's what it means. So whatever we do to one side, we must also do the same to the other in order to keep the expressions having equal value. That is what we call the equality property. It refers to many of the properties that you use, whether it's addition, subtraction, multiplication, or division. To keep the equation balanced, you must perform the same mathematical operations to both sides. The final term to review here is solution. Solution refers to the answer. After you have solved the equation and isolated the variable, the solution is the value that you can put in place of the variable that makes the equation true. In algebra, it's best to write the solution in the form of the variable, the equal sign, and the value. As you progress in algebra, you will have equations with different variables. So it's always best to get in the habit of writing the solution in the proper form to make it easier for later to distinguish if there happens to be more than one variable. Now let's try some examples. There is an activity on illuminations.nctm.org website which allows you to use algebra tiles or pieces to represent the equation to help you see how to use inverse operations and equality property in order to solve an equation. The link is provided here in case you want to access it again on your own for individual practice. But for now, we'll do some examples together. If you look at the equation, -4 equals -2x minus 4. Again, since it is an equation, it is saying these two expressions, -4 and the other expression, -2x minus 4, have equal value. So we need to determine what is the value of x so that when we simplify this expression or do all of the math we can, its value will also be -4. So on this side for a review, I've listed the main steps in how to solve an equation. First, you want to check to make sure that all terms with the variables are on one side of the equation. So if we look here, we have a -4 on one side, -2x minus 4 on the other. All variables are on one side. The next step, step 2, is to make sure we move all constants to the other side, move them away from the variable. So when we look here, we're focusing on this term. This is the term with the variable and the constant. And we have -4 on this side, and we want to remove it to get it over to the other side. So we are going to use this model. We're going to build the model, and then it will show how to help move the constant to the other side so that we're only left with the variable. So let's start building our model. First, focus on the term on the left, -4. Come over to the right-hand side, and we see we have a 1 here. However, it is positive. We use this button, select this button, and it is now negative. Select the -1 and drag it to the left side of the model in order to represent the term on the left side of the equation. But 1 is not enough because we have 4 negatives, so we need to move 4 negative 1s onto the left side of the screen. We are then going to focus on the right side. This line represents the equal sign. So here we have negative 2x. Well, here's our negative x bar. So we're going to drag that, and we need to drag a second to represent negative 2x. And we also have negative 4. So we need to drag 4 individual negative 1s. Our model now represents our equation. 4 negatives on the left, 1, 2, 3, 4. The equal sign is represented by the line. 2 negative x's on the right, as well as 4 negative 1s. The program has a built-in check, so you could check to make sure that your model matches the equation. You simply select the check button, and it will let you know that it's correct. When it's correct, it then writes the box that would be for the solution. So now we want to isolate the variable. Remember, the variable is represented here by the longer boxes of x. We want to remove the constants. Since these are negative, the inverse would be positive or plus. So we come back over to the right. We select this button, which toggles between positive and negative, and we're going to add 4 positive 1s to the right because we want to remove those 4 negative 1s. And the equality property, remember, we're always using the equality property, tells us that if we added 4 to the right, we must also add 4 to the left. So right now, when we're looking at this, if we were writing it, you would have a plus 4 under the right and a plus 4 under the left to show that we have added 4 to both sides. These are called zero pairs because they cancel each other out. So the way we get them to cancel, simply layering them over each other will not remove them, although it colors differently. The way this program works is you come up here to the right. This symbol is for zero pairs. You select that, and then you click the pairs that will zero each other out. Positive and a negative is a 0, positive and a negative 0, positive, negative, and you continue that until all of the zero pairs have been removed from both sides of the equation. We are now left with 0 on the left and 2 negative x's on the right. So we need to ask ourselves, what does it mean if 2 negative x's is 0? Then the value of each x must also be 0. When you finish, you type the 0 into the bar and then select the check mark in order to check to make sure that your solution is correct. Now let's try an example with variables on both sides. First, we build our model. Negative 3x plus 5 is the expression on the left. Negative 2x minus 1 is the expression on the right. So we drag 3 negative x's and 5 positive 1s. There's another option here that duplicates. So you can then just arrange them to show that there are 5 positive 1s. Now for the right, 2 negative x's, change it to a negative, drag 2 negative x's, and 1 negative 1. Then we check, and we know that the model now matches our equation because the solution box came up. So now we want to make sure that we have terms with the variables on one side and constants on the other. So here we have x's on both sides. You could choose whichever way you want to do it. I usually take, if there's negatives, I start there. I want to move them over. I prefer to work with positives, so I'm changing this to a positive. So I have to put 3 positive x's on this side. And it doesn't matter, they don't have to be next to each other because what you're then going to do is use the 0 bar. Okay, so we need 3 x's on both sides. We put 3 x's on the left, 3 x's on the right. We now use the 0 pairs, and we have a positive and a negative, a positive and a negative, a positive and a negative. Do it to the other side, a positive and a negative, a positive and a negative. So we are now left with x's only on the right-hand side of the equation. So now we have done that part where we have all variables on one side. We now want to move the constants to the other. So again, we're working with inverse operations. We have a constant on the right. We want to move it to the left. It is a negative, so in order to remove it, we are going to need to add a positive. The equality property says whatever we do to one side, we do to the other. We now use our zero pair tool, and we select positive and negative, which removes the constant from here. We are now left with constants on the left and the variable on the right. So we have 1x, and we have 1, 2, 3, 4, 5, 6 singles, 6 ones. So our solution is x equals 6. Use the check feature, and we have now used these tile models to show the solution that x equals 6 in this equation. The best thing to do now is on paper notebook, write the equation, substitute the 6 for the x on both sides, and make sure your equation balances. Feel free to try another problem by hitting that paper and refer back to this video and notes as often as needed. Good luck!